Professor Bialis here. In this video we're going to be talking about section 7.6, which is proportion and problem solving. Again, problem solving just means word problems, but we're going to be dealing with what's called a proportion. So before we get into the word problems, I want to delve into the proportion idea a little bit. So again, this is section 7.6. And we're going to start with a couple of definitions. First one is ratio. Okay? A ratio is simply a comparison of two values, sometimes more, but we're sticking with two right now, of two values using division. Okay? A sum of two values using division. Okay? So when we deal with comparing values, there are a couple ways that we typically would see this. Let's say we have 2 cups of sugar for 5 cups of flour, for instance. So 2 cups of sugar, 5 cups of flour. That's a ratio. What you may have seen in the past is a ratio written like so. There's nothing wrong with that. However, when we do it like this, it's not as easily manipulated mathematically. Okay, so fractions are fractions. We can add them, subtract them, and all that. But once we write it like this, then we lose some of those applications and those possibilities. So while this is not wrong, we're going to stick primarily with this. Okay, so that is a ratio, just comparing two different values. Now, a proportion is what we're going to be using, because a proportion is an equation. Okay, that's something we can solve and work with. An equation in which two ratios are equal. Okay? Now, this is the type of equation that we're going to be setting up with the word problems that we cover in this section. But before we deal with word problems, I want to talk about just solving a standard proportion. So let's look at a couple examples of that. Let's start it simple. Let's say 3 over 8 equals 63 over x. Okay? Now, you could multiply both terms by the LCD of 8x. That's perfectly fine. Okay. However, when it's just a plain proportion, fraction equaling fraction, there's another way that we could do it. Okay. What we could do is, instead of multiplying both terms, we could do what we call cross multiplying. Okay. Now again, that only works when we have a fraction equaling a fraction. Then we could do it. So when we do that, we multiply 3 times x and then 8 times 63. Okay, 3 times x I would just write as 3x. 8 times 63, if you can do that in your head, great. If not, again, it's times like this that it's a good idea to practice those arithmetic skills. 8 times 3 is 24, carry the 2, and then we've got 48 plus 2 is 50. So we've got 504. We would then finish this by dividing by a 3. X equals, and then again, don't be afraid to practice. Okay, 3 goes into a 5 once. You got a 3. 2, carry down that 0. 3 goes into 20 6 times to get an 18. You got a 2, carry down that 4. 3 goes into 24 8 times. 3 times 8 is 24, and we have 168. Okay? And there you have it. Nothing more to it than that. If you did think, okay, I'm going to clear fractions, you would end up with this exact same equation right here. Again, what's nice about this is you don't have to think, what's my LCD? I can just use whatever numbers are in front of me. Okay? Let's do one more. again, I could look at that and say, well, the LCD is 35, so I'm going to multiply both sides by 35, or simply cross multiply, cross multiply. We have a 5 times 2x plus 1, and we have a 7 times x minus 3. Okay, distribute. And then solve from there. I'm going to subtract a 7x to get 3x plus 5 equals negative 21. I'm then going to subtract 5 to get 3x equals negative 26, and then divide by 3. And there we have it. Okay, so again, this is a kind of a shorthand way of clearing fractions, solving a rational equation, but only rational equations that have a single equation equals a single equation, making it a proportion. Okay, so now let's get into the actual application problems that are in this section and see how those kind of play out. Just like in previous sections with word problems, they are going to have some very specific examples, specific types of examples that are worked out in the book. They will then give you a practice problem. That's what I'm going to be covering here. But I want you to look at each type of problem as its own kind of category. Okay? So what I'm looking at here is practice 3. And that is found on page 489. Okay, so that reads, 4 2-liter bottles of Diet Pepsi cost $5.16. How much will 7 2-liter bottles cost? Okay, so this is what I like to call a comparison problem. You are comparing two different values. In this case, we're talking about the price and a number of bottles of Pepsi. Okay. So let's look at that again. It says 4 2-liter bottles of Diet Pepsi cost $5.16. What are we talking about? We are talking about and comparing number of bottles and the cost. Now, it does not matter if you go number of bottles cost or cost the number of bottles, as long as you're consistent. That's why I really suggest write this out so you can stay consistent the rest of the way. Now, they tell you one ratio, one comparison. 4 bottles cost $5.16. So we've got 4 bottles, $5.16. Okay? Next, how much will 7 2-liter bottles cost? So, 7 bottles, I have no idea how much that is going to cost. Okay, so I now have my proportion here that I can solve. Okay, when I solve that, I'm going to do my cross multiplication. I have a 4x, and then here I'm going to have to multiply that out. Again, $5.16 times 7, that's a 2, carry a 4. 7 plus 4 is 11. 35 plus 1 is 36. There were 2 decimal places here, so I moved 2 decimal places back. So I have 36/12. I then divide by 4, and then I have to take 4 going into 36/12. I bring that decimal right up. 4 goes into 36 9 times. 4 times 9 is 36. I carry the 1 down. Now, look at here. 4 does not go into 1, so I put a 0. But then I carry over to the next thing, which is a 2. 4 goes into 12 3 times. So 3 times 4 is 12, and I get a 0. So what I get for my x is 903. That is the cost for 7 bottles. Okay? There you have it. You are just comparing two different values. Write out the order that you're comparing them. Doesn't matter, just pick one and stick with it. And then they give you one full comparison and then one comparison that we're missing a piece of. Now, some of you may be thinking, well, why did we go through all that? Well, I could have just said, $5.16 divide by 4, get the cost per bottle, and then multiply by 7 bottles. That's perfectly fine. That's exactly what we did here. We just switched the order. Instead of dividing by 4 and then multiplying by 7, I multiplied by 7 and then I divided by 4. So again, if you're thinking like that, that's fine, but please don't think, well, this is so much harder and so much more work. It is literally the same thing. And when there's more variables put into here, when the numbers aren't so nice, we have this structure to fall back on. So while thinking in those, more just kind of plain terms, that's perfectly fine. Please don't discredit this, because this is a very good tool when there's too much to just be, jumbling up in our head. Okay, so let's look at another one. Let's go on to practice 4. Now, practice 4 says, if the following two triangles are similar, find x. If the following two triangles are similar, find x. And they give you triangle like this and a triangle like this. Okay? If you remember from geometry, similar would be denoted with that little squiggly line. Now what they give us is 20 meters, 15 meters, and then 8 meters and x meters. Okay, now if this was a true geometry class, I would label the vertices, I would tell you the orientation of how they're similar and all that stuff. Okay, but since we're just kind of getting the idea of solving the equation down here, what you see is what you get. Okay, now when things are similar, what does that mean? Basically, they're the same shape but different sizes. What that tells us about the sides is that they are proportional to one another. Okay, so what I'm doing is comparing two different triangles. Just like I had a comparison problem here, it's just now they're triangles that I'm comparing. Now, how you compare it is completely up to you, as long as you're consistent. The way I like to do this is simply the big triangle to the small triangle. You could go small to big, you could go bottoms to tops, anything like that. Just stay consistent. So, how do I compare these? The big triangle has this bottom piece as a 20, while the small triangle has a bottom piece that's an 8. The big triangle has a side that's 15, while the small triangle has a side that's x. And now I have a proportion that I can solve. Okay? So I am going to cross multiply. I have a 20x equals, again, I have a 40, 8 plus 4 is 12, so I have 120. Divide by 20. And x equals 6. Okay, so in this case I'm dealing with 6 meters. Okay? So again, this is basically another comparison problem. It's just we're comparing two triangles. Now the other thing I want to be very clear on, I don't want you to ever get a different answer here, or a different answer from the back of the book or whatever it is, and say, well, I just must have, rearranged this a little bit. It's fine. It's not fine. If you rearrange this in a different order, different layout, if it's correct, you still should get that 6. If you're getting something different, something is wrong. You weren't consistent somewhere along the line. So go back, find that inconsistency, and fix it. Okay? Let's move on to practice 5. So practice 5 says, that's on page 491. It states, the quotient of a number and 5 minus 3 halves is the quotient of the number and 10. Find the number. Now again, just like all word problems, I read through it once just to get an idea of what we're talking about. Here we're talking about numbers. As always, if it's a number problem, you translate. That's it. You just translate the problem, okay? We always want to translate up to the equal sign, and then we translate the second side. So again, it says, the quotient of a number in 5 minus 3 halves is, I stop there because is means equals. The quotient of a number in 5, comma, minus 3 halves. The quotient of a number in 5 minus 3 halves. Quotient of a number in 5 minus 3 halves. That comma was very important because it said do this quotient, then subtract the 3 halves. Without the comma, the quotient of a number in 5 minus 3 halves. If there was no comma there, I would be writing this. But the comma tells me to keep those two separate. Okay, so be very careful with that punctuation. That is the quotient of the number and 10. Find the number. Quotient of the number and 10. Simple as that. Okay. I see some students write, when they say quotient of a number and 5, they write it like that. That's not wrong, but it's not very algebraically accessible to us when we're solving these. So try and write quotients, division as fractions. It's a lot easier to work with. Now, once we have this, can we cross multiply? No. Okay, because to cross multiply, we need a fraction equals a fraction. Here we've got 2 fractions and then 1 fraction. So this is going back to the basics of a rational equation. So I'm going to make sure that negative is attached to something, and then I'm going to multiply all terms by the LCD of 10. 10 divided by 5 is 2. I have 2x. 10 divided by 2 is 5. I have negative 15. 10s are gone. I get x. Okay. Now, when we're solving this, typically we're going to bring that x over. Please be careful, because we got x minus 15 and a 0. Don't lose that 0. A lot of people want to say, well, there's nothing there. You're right, there's nothing there, but we need to show that with the 0. And then we add a 15. And there's your number. Okay? That's pretty much it. Translate, solve, move on. Let's look at the next one. Practice 6. Practice 6 is found on page 492, and it reads, Cindy Lou and Mary Beckwith own a landscaping company. Cindy can complete a certain garden planting in 3 hours, while Mary takes 4 hours to complete the same job. If both of them work together, how long will it take to plant the garden? Okay, so this is what I like to call a work problem. If you are in any kind of management position, or you go out and give estimates to customers, you need to be able to estimate your labor costs. How are you going to staff certain shifts? How are you going to charge a customer? And so on. This is exactly what this is talking about. Okay, so again, I read through it once. I have Cindy Lou and Mary Beckwith. They own a landscape company. Okay, they own a company. That's fine. Now, they are always going to give you 2 people, 2 objects that are working, something like that. But in this case, we've got Cindy Lou and Mary Beckwith. So we've got Cindy and we've got Mary. Okay? Now, it says, Cindy can complete a certain garden planting in 3 hours, while Mary takes 4 hours. So what's happening, then it asks, if both of them work together, how long will it take? So we want Cindy and Mary to combine forces, and then they're going to get the job done together. Okay, this is always going to be the situation that we're presented with. Okay, now again it says, Cindy can do this in 3 hours, Mary takes 4 hours. Okay, what a lot of people want to do is say, okay, Cindy's 3, Mary's 4. Okay, then what do? Well, we add that and we get 7. Does it make sense that if Mary can do this in 4 hours, then if she has help, it's going to take 7 hours? It should take less time. So what we're doing is not comparing times. We should be comparing rates. Now, a rate is a speed. So instead of 3 and 4, watch how I'm going to write this. If Cindy can do the job in 3 hours, That means per hour, in 1 hour, 1/3 of the job is done. Same thing with Mary. If it takes her 4 hours, in 1 hour, 1/4 of the job will be done. Look at how I built that. I just did 1 over the time, 1 over the time, 1 over the time. That's it. How long is it going to take them to do it together? 1 over, I don't know what time. There's nothing more to it than that. 1 over the time, 1 over the time, 1 over the time. Just be careful that you're putting the numbers in their correct spot. Because sometimes they'll say, Cindy takes 3 hours. We don't know how long Mary takes. Together it'll take them 2 hours. Then I would put the 2 here. Okay, so make sure you're putting them in the correct spot, but it's always 1 over that time. And then after that, we have to solve this equation. Okay, so we can't cross multiply. I'm going to multiply by that LCD of 12x. 12 divided by 3 is 4, so I have a 4x. 12 divided by 4 is a 3, so I have a 3x. And here the x's go away, so I have 12 times 1 is 12. Combine. Divide by 7. And leave it as that. What we were looking for is 12/7 hours. Okay, very easy problem once we know the setup. Okay, 1 over the time all the way through. That's really all we need to remember and utilize. Okay, let's move on. Let's go to practice 7. Okay, practice 7 is found on page 494, and it reads, a bus travels 180 miles in the same time that a car travels 240 miles. If the car's speed is 15 miles per hour faster than the speed of the bus, find the speed of the car and the speed of the bus. Now, we read through it once, maybe twice, and we know we're talking about a car and a bus, and they're talking about distances, rates, and times. So what we have here is one of those problems where we have 2 scenarios, each with their own distance equals rate times time. Okay? Now, what are those 2 scenarios? Well, we have a bus, we have a car. Okay? You may need to read through that problem 3, maybe even 4 times to get this far, and that's okay. Expect that. Okay, that's normal. Now, we have 3 categories of information. 1 category is going to be given to you, 1 will be described, and then we use those 2 to create the 3rd. Okay, so let's go back in and get those pieces of information. It says, a bus travels 180 miles in the same time that a car travels 240 miles. So what they gave us were distances, clearly given distances. Bus travels 180 miles in the same time that a car travels 240 miles. Now, whenever they say something's the same, remember that, but don't write that down just yet. We have the same time though, okay? Then it says, if the car's speed is 15 miles per hour faster than the speed of the bus. Car is 15 faster than the bus. We have no idea how fast that bus is going. But I know that car is going 15 faster. They gave it to us, they described it to us, and the time is going to be a combination of those other 2. Okay, now how do we get that combination? Okay, the combination is going to come from the original formula. So what I mean by that is, we know that distance equals rate times time. But if we're working with time, time is distance over rate. So while we don't know anything about the time, we can describe the time algebraically. The time is the distance over the rate. The distance over the rate. Given, described, we build this using the other 2. Now that thing we build is typically going to be where we find our equation. Now they did mention a little bit about the time. They said that these distances were covered in the same amount of time. So if I know that the time for the bus is 180 over r, and the time for the car is 240 over r plus 15, those times better be the same. And now we have just a basic proportion that we can solve. So I'm going to cross multiply. Okay, we have 180 times r plus 15, and we have 240 times r. And now we work through it from there. Okay, so I distribute. I have 180 times r, and then I have 180 times 15. Watch how I'm going to do this. I'm going to take 15 times 180. Do you see how I push that 0 off to the side? I can just multiply 15 times 18. So that gives me a 40, that's a 12, start with a 0, and then I have 5 and 1. So that gives me this, and this extra 0 that was trailing off at the end, I just carry down. So I have 2,700. Okay? Now, I go from there. If this is kind of throwing you off, then just write it, like this. It's not the end of the world. This is a little bit more useful when there's a lot of zeros tracking at the end. You don't have to keep copying them through the whole problem. Okay, so with this, I forgot the r. We're at this point here. So then I'm going to subtract 180r to get 2,700 equals 60r. I then divide by 60 to get r equals, again, I can just take out that factor of 10. So what I have is 270 divided by 6. 6 goes into 27 4 times to get a 24. So I get a 3, carry down that 0. 6 goes into 30 5 times. 6 times 5 is 30, and I get 45. So I solved it. Okay, that's good, but I need to interpret that answer, interpret that solution I got. So what they said was find the speed of the car and the speed of the bus. That R was found in the bus's row. Okay, so that tells me that the bus is going 45 miles per hour. The car is going 15 more than that. 45 plus 15 is 60 miles per hour. Make sure you specify which is which. Don't just say 45 and 60. 45 for the bus, 60 for the car. Okay? Let's do one more example to finish this section up. Now this example I want to pull from the exercises in the book. So if you're using the e-text, then this is actually number 26 in the book. Okay, 26 says, a boat can travel 9 miles upstream in the same amount of time it takes to travel 11 miles downstream. If the current of the river is 3 miles per hour, complete the chart below and use it to find the speed of the boat in still water. Now, the chart below gives you a little bit of a partially completed chunk of information. I don't want you to rely on that. I want you to be able to make the chart on your own, start to finish. So let's see how that's going to look. Now, again, read through it 2 or 3 times to get the idea that we are still talking about 2 scenarios, each with their own distance equals rate times time. Okay? Now, if we go back to the problem, the 2 scenarios are not 2 boats or not 2 people. It's a single boat going upstream and then going downstream. Okay? Now, same as always, something's going to be given, something described, and then we're going to pull those two together to get the third. So let's go back in. It says a boat can travel 9 miles upstream, same amount of time, 11 miles downstream. So again, they give you those two distances and they say same time. Hold on to that same time for a second. So it says 9 miles upstream, 11 miles downstream. Okay? Then it says if the current of the river is 3 miles per hour, complete the chart below. Okay. So the current of the river is 3 miles per hour. Now, that brings us to the rate. The rate that a boat is going when it's on a current like that is going to be a combination of the speed that they're pushing themselves at, as well as the speed of the water itself. Okay? When we are going upstream, think about walking uphill. We're going against the current. So the boat's pushing itself at a certain speed, but then the current is kind of holding it back and slowing it down a little bit. So whatever speed the boat is pushing itself at, when we're going upstream, we're getting slowed down by 3 miles per hour. When we're going downstream, we're coming the other way. So now that current is helping us along. So what we have is the speed of the boat plus 3 miles per hour. And that should make sense when we look at the distance, because when we're going a little faster, we're covering more distance. Okay? It's the same as if you're in a shopping mall and you have the escalator. If you are walking with the escalator, you could just be walking very slowly, but it feels like you're flying because it's your speed you're walking at plus the speed of the escalator combining to your overall rate. If you're going the opposite way, you could be running as fast as you can. It looks like you're going nowhere because that escalator is holding you back. Same idea with this. Okay, now, when we have the times, remember, they did mention the times were the same, but we have to represent that time. Distance equals rate times time. Means time is distance over rate. Okay? You don't have to memorize this. Do what I did right here. It takes a few seconds. So distance over rate is 9 over b minus 3 is 11 over b plus 3. And remember, they were the same. So this time should be the same as that time. And that's it. So I'm going to cross multiply. I have 9b plus 27, 11b minus 33. I can then solve. Subtract 9b, get the variable on one side, and then I can add a 33. 27 plus 33 is 60, and then divide by 2, and b equals 30. Now make sure you answer the question. The question was, find the speed of the boat in still water. Okay? Now, the speed of the boat in still water is when you don't have that current factored in. That's what the B stands for. That's what we found. So the speed of the boat is 30 miles per hour. And there you have it. Okay? So when we deal with these word problems, again, categorize them. We had comparison of two things, okay, where we said number of bottles and cost. Then we had the similar triangles, which was really another comparison of two triangles. We had a number problem where we just translated. We had a work problem where it was 1 over the time, 1 over the time, 1 over the time. And then we have these distance problems here. Okay, that's really it. So make sure you categorize them nicely. You remember the general plan of attack for each of those categories, and then you will be fine. Okay, take your time. As always, work hard. Let me know if you have any questions, and I'll see you next time.